All right, so welcome to the sixth session of the hardware training. So in the previous session, we ended at the place where we're designing um, the schematic for a project that we chose. Okay, so in this particular session, we are going to continue. This will be the last session that I'll do on KiCAD specifically, because, like I said, this is not a KiCAD training. It is KiCAD is just supposed to be one of the things you get to experience through this training. Okay. Yep. So this will be our last training on KiCAD specific topics, and then tomorrow, God willing, we are starting with our project, and the rest of the things that I would like to teach will all be done along with the project. Okay, actually, that is the whole idea, but I want to clear these things from the way, so that once I'm talking about things, it wouldn't be like everything is new to everyone. Okay. All right, so thank you for joining, and I hope you guys are enjoying the lectures. So this is where we left off. Let me project it. Share the screen. Okay. All right, so this is where we left off. Okay. Um, the whole thing we are trying to do is that we did a project, not a project. We There was a sample project that we talked about when we were doing the uh, basics, right? And we are trying to build that, right? Now, the last thing we did for the basics and concept is we did that calculation for we did a calculation for that project, as in the garage thing that we're talking about. Okay, so right now we are trying to build the project. Okay, we are trying to build a PCB for the project so that we can use it as a way of learning about KiCAD. Okay, yes. So the last session that we had, we ended at the point where we we said that our power was gonna come from somewhere, and we needed a way to inform KiCAD that, look, our power is coming outside of this circuit. So anywhere we put this thing, that is a source of our power. Okay, and so we put in this connector that we call a DC barrel, right? And I showed you that this is how physically the DC barrel looks like. Okay, it's a very common connector on radio sets and other DC related stuff. Okay, all right. So looking at the project that we calculated, we did, it was just the lamp and the resistor and the battery, right? So basically, we don't have much to do here. But then I want us to actually add a battery to it. Sorry, a switch to it, so that we can use it to toggle the power on and off. Okay. So basically, when before you build this circuit, the most important thing is, one, you should know your components. Okay, the names of your component and how they physically look like. That will be the footprint. Okay, if you don't know and you choose anything at all, you will end up having issues. Okay, so we want to also put a switch on it. Okay, so let's go and look for a switch. Now in this case, you're going to look for a very simple switch, and once again we will go to the component placement to pick up the switch that we need. Okay, now where is it ideal to connect a switch? On the positive line or on the negative line? Is it ideal to connect a switch? Any answers? Mm-hmm. Where is it ideal to connect a switch? On the positive line or on the negative line? Yes. Okay, KiCAD is taking some, machine is taking some heat. Hmm. Oh, come on, don't waste my time. So tomorrow upwards, onwards, we will start designing our projects, and like I said, the rest of the concepts would all be explained during that time. Okay, so tonight is the chance, your chance to, I mean, get familiar with the KiCAD, and also if you want to be practicing along, then make sure you get your PCB set up and all that. In fact, it will be nice for you to practice along. Okay, yeah. All right, so we are looking for a switch. Now we can type SW, or if we have the actual switch, we can also just type the name and see if we have it. So you can see that my library has popped up. Okay, but because you don't have access to my library, I'm not going to select that. So yes, let's look at the switch library. Now there are so many types of switches. That's why I was saying it is very important that you know the name of the switch you are looking for. Actually, at the moment I don't have idea of what I want, but then I know I want something like this, something that toggles between 2 points, right? But then I'm going to play my card and see if I can get something that already has a footprint. Okay, definitely all the switches here don't have, but what I need is something with a single pole and a double throw. Okay, I need a single pole double throw, single pole double throw. So that's, so this is push single throw double throw. So I can set for SPDT, right? Great. Oh, and it's bringing it from my library. I don't want to use anything from my library. All right, so we will go with this one. Oh, but this one is made up of two parts. We want, yes, so I think we can just go with this switch single pole double throw. Is that okay? So that's what I was saying, that you should know the thing you are looking for, because KiCAD's naming convention is some way, and you should know how to look for your stuff. So yes, this is what something we want, but then there is no footprint attached. That means once we are attaching the footprint, you have to make sure it has 3 pins, and that's in that order, right? Okay, so I'll select this and bring it here. Now it's ideal to connect your switch on the positive line. Okay, you don't want the energy to travel through the circuit and just wait for a gap to terminate. You rather want to block it as far as your circuit is concerned. Okay, now probably those who already know how to work with circuit, you are asking, why am I not going to put any capacitors on this? Of course, I'm not going to put any capacitor on this. Okay, just going to build it to be as simple as possible. Besides, it's an incandescent bulb we want to hook up to a battery, right? So I mean, there is no need to waste components in this case. So this is the switch I'm going to use. You can see that the pole, the pole is on pin 2. Okay, so that means I'm guessing something like the pole will be in the middle, right? And it is normally closed on pin 1 and normally open on pin 3. Either way, we can connect our throw anywhere, but I'm just going to keep to this. So I'll link this part to the battery. So one part of the switch has to go to the battery. Now technically this part that has to go to the battery is the throw, the pole, sorry. then the throw goes to our circuit. So we can now connect from here, or we can even choose to connect from here. Let's just connect from here to the rest of our circuit. Okay, so take note here, we labeled, or we have put the battery flag to this point. Okay, and this point comes, this battery flag comes before the switch. Okay, so technically we need another power flag that will represent our 12 volt, which will be the switched voltage. Is that okay? The switched voltage. So I'm going to add another power flag. This time around, that power flag is going to be a 12 volt power flag. So let's pick it. So I need 12V. Unfortunately, there is a 12V, so I need 12VP. I'll put it here. So this is going to be the working voltage for the circuit. Okay, and once again, I will define it as a power source. Okay, so right after the switch, I will tap that here. Okay, I think because of this, let me just hook this guy here. Okay, so the battery only ends here. Anytime you want to connect anything to the battery, then that thing will have to be connected before the battery. Once we switch it, we will now refer to as the 12 volt source. Is that okay? Now in KiCAD, you are not allowed to leave a pin unconnected. In KiCAD, you are not allowed to leave a pin unconnected. So if deliberately you want to say this pin is not connected in your design, then you have to specify it by using the no connection flag. Okay, so if you pick this icon here, if you look at, you can see that add no connection flag, or you can press kill for that. So if I press on this, then I can put it on. So this tells KiCAD that I am aware this pin is not connected and it's a deliberate attempt. Okay, it's a deliberate action. So this will make KiCAD's ERC checker, ERC silent. Is that okay? So anytime you are not going to use a particular pin, so far as the pin is defined on the component, you have to put on this no flag, no connection flag. Okay, so our battery connects to this port. Once we switch it, we will call it the 12 volt source. Okay, so this helps us to distinguish between where our battery is connected and where our load is connected. So everything concerning our load will come after this point. Okay, now basically this is where, when I am designing circuit, I would like to leave this. So this side becomes my power input, and I will gladly secure it. So here, call it power. So let's give it a name, let's give it a title. Let's call this power input. Power input, okay, because this is the input of power for our system. Now take note that I have deliberately decided not to put in any capacitors. Okay, I'm not going to put that. So now we have our connector for our battery, we have our switch. Okay, the next thing we have to do is our lamp. Again, our lamp is not actually a component that can sit on the PCB. That means that our lamp definitely has to be connected through a connector. Is that okay? We have to put a connector on our board to connect our lamp. Now, incandescent lamps are typically not polar. Okay, if I say something is not polar, it means that it doesn't actually specify a positive terminal and a negative terminal. Okay, so either way you can connect it and everything will be okay. But there are things that are polar. You have to make sure positive goes to positive and negative goes to negative, right? But the incandescent bulb that we are talking about is not going to be polar, or we should assume it's polar. All right, let's assume it's polar. Is that okay? let's assume it's polar. So if it is polar, then we have to be careful about how we connect it. Is that okay? But I am still going to use a screw terminal. Remember earlier in the previous session, I showed you a screw terminal block. Okay, so we are going to use that as the connection point for our board. Is that okay? As the connection point for our board. All right, so let's add that. So we need a screw terminal. So let's go and pick it. The name is, as I said, so we call it the terminal block. Terminal block. So terminal block. All right, this time I'm going to use something. Okay, let me just, for the sake of, okay. Let me see. Yes, so screw terminal block. Now we need something with 2 pins. Okay, so you can see that we have a screw terminal block with 1 pin, 2 pin, and that or that. Well, we need something that has 2 pins. Okay, so we'll pick this one and then use it. Okay, so this is where we are going to connect our load. So let's give it a name. You hit V to give it a name. So let's call this bulb or lamp. Is that okay? You call this lamp, and you can always move the references and values around as you want. But take note that in our circuits, this thing was connected to a battery, a resistor before connecting to power, right? So we really need to go and bring our resistor. Now, after this, I'll show you something. Okay, you are probably you can probably see that I'm designing the circuit in some way, right? So let me just make things easier for you. Or I mean, it is still okay. So don't worry, just follow. We need a resistor. The resistor that we wanted, we calculated was a 3 ohm resistor, and it was supposed to be 3 watts. But I said that for the purpose of quality and faster cooling, my rule of thumb is to double it and use a much higher wattage, right? So we use something like 5 watts or 6 watts, okay, by doubling it. So let's go and pick a resistor. Resistors are labeled R in KiCAD. So if I hit add symbol and then bring up the dialog, if I type R, okay, this is for resistors. Is that okay? Now the R, we have 2 types. Remember I said we have 2 types of symbols. We have the international ones and we have the US version, right? So if you want to use the US version, you can type something like RUS. Now the US version uses the zigzag thing, right? But the international one uses the box thing. Okay, good. And there are smaller versions of them. Okay, so if I want the small one, I can just say R small, because usually I don't want my things to look too big. Okay, so press R to rotate it as I want and mount it here. Okay, and the next thing is I'll set its value. Remember, it was what it was, the value was supposed to be 3 ohm. So in KiCAD, 3 ohm, you would say something like 3R. If it is 3000 ohm, you say something like 3K. Okay, 3 meg in that order. Okay, so R represents ohm. Okay, that's something that we do. Okay, then I usually like to clean up, move things about. So you select and you press M and you move it. Okay, now the next thing is, this was supposed to be connected to our 12 volts or our battery. So let me move this guy down here and then put this guy here, and I can conveniently put this here. Okay, now I will advise that always make sure there is a space. So don't do your connections like this. Okay, sometimes it may not connect and you won't see. So I rather prefer always having a little space and deliberately connecting the wire between them. Is that okay? That way, if something doesn't connect, it is easy for you to know that it's not connected. Okay, so from our power source through the resistor, then from the resistor to the lamp, and from the lamp to the negative rail, and the negative rail is what we call the ground. Okay, so basically that is our circuit. Now you probably can see that I've designed this circuit in a different way than we did when I showed in the PowerPoint, right? Yes. Now most of the time this is how you see professionals design circuits. Is that okay? We don't do that box thing. So technically some of you were looking for something like this, so let me do and explain something quickly. So you are used to most of the new ones you are used to, so I would have chosen a battery, and then I'll choose a battery, and then I'll bring the switch, and then the resistor, and then the connector for the bulb, and then that. So some of you probably you are used to this. Okay, used to this. Yes, you can do this, but it is really not very uh, for me. I don't like designing circuits like this, right? They tend to waste too much space. They tend to waste too much space. I don't like design. So this thing you are seeing here is equivalent to what I've done here. Is that okay? So just that I have put separation between the various parts. So this is my input, power in to the switch, right? So anywhere I connect this 12 volts, they will technically be connected together. Is that okay? Now if you want to see in KiCAD, if you want to see whether where a net connects to, just click on this second button here and click on that icon. So if I click on this 12, you see everything that is connected to this 12 volt net would get highlighted. Is that okay? Good. So this that you see here is basically that. So basically what I've done is split it, right? Because technically we will connect this part to ground like this. Okay, so I have splitted it and brought this ground here. This also is supposed to be our 12 volts point, so technically something like that. Okay, and this is supposed to be our battery point. That's the circuit, but doing it this way is not nice for me. Okay, I prefer to split. So higher potentials point up, and then lower potentials point down. So when I do things like this, I'm able to nicely arrange my circuit and all that. So take note that every place with 12 volts connect this 12 volt flag, it means that they are connected together. Is that okay? And any place that would have this battery flag, it means they are connected together. So as it stands, this 12 volt is not connected to this battery. Okay, but this 12 volt is connected to this pin 3 on the relay. So it's just as we have done here. Okay, so you won't see me design circuits like this. Okay, no, we don't do this in this town. Okay, we will be designing circuits this way. So in this case, you can see that I've nicely separated the inputs and the output, right? So I can now put its own title here, so something like lamp. Okay, so if you take this circuit, and it is easy, so I've kind of made it modular, right? If you don't have to worry about the power input and you just want to figure something out at the lamp side, you just go there straight up. Okay, in programming we call this object oriented programming modularity, right? We call it modularity. So I have kind of splitted the circuit into functions, okay, and group them, but basically they are all connected together. Okay, this ground point and that ground point are connected together, though you don't see any physical connection between them. So far as this is here and that is there, it means they are connected together. This 12 volt and that 12 volt are connected together. Is that okay? So basically that. I like to design circuit this way because it makes it neater. Now looking at, we are done. We are basically done with our circuit. That's all that was required for our circuit, right? So we are done with the schematic. You can see we know our input component. The only component that needed calculation is this resistor, and we have already done that calculation in the in a previous session. Okay, so we are done, but I don't like these spaces around here, so I'm going to change this block, and instead of using A5, I'm going to set it to user custom and set my own heights. Okay, so for the heights, I'll try with 180, and for the width I'll try with 150. Okay, I think 150 will be too much, so let's say 140. 140 will be too much. Let's say 135. Now, if in case you are wondering how I'm saying it's too much, I'm looking at this. Okay, I know the circuit is enough to sit on top of just the title block side, right? So I'm just closing this space. Now, in terms of the length, is too much. 180 is too much, so let's try 130. So we have something like a square. All right, now you can see, as I said, and even there are still too much space. Let's go and clean it up a little bit. So I think there is a minimum that you can set. Let's say 100. There is a minimum that can be set. Okay, so 100 actually works for our circuit. So the next thing that I'll do, and take note, what I just did is not necessary. It's just me cleaning my circuit. Okay, it's not something that is really important. Okay, so clean and just adjust these lines so that I have a very neat circuit schematic diagram. Oh, come on. All right, delete this guy, and then delete this guy too. Let's move this guy about. All right, and I have a nicely formatted circuit, right? Let me hit this, and I can get rid of that and that and that and that, but then I still need, okay, so I think I can actually move this space them out a little bit. Okay, move this line a little bit. Okay, duplicate by using Ctrl D and put this here. Okay, and then I can drag and select. Okay, so you click and you drag and you can select it, and just like that I have my circuit ready. Okay, so basically we are done with the schematic of that simple circuit that we are working on. Okay, so any questions up to this point?